Welcome students, we are back with another lesson. In this lesson we will discuss the images formed by spherical mirrors. So in this topic I will state the rules which are used for drawing images formed by spherical mirrors. Fine. So your first rule states that a ray of light which is parallel to the principal axis of the mirror passes through the focus after reflection from the mirror as shown in the figure. Now let us understand for your concave mirror. In case of your concave mirror, let us consider this is your reflecting surface which is a concave mirror. Fine. For this concave mirror, the mirror has a center which is known as your pole, and it is denoted by capital P. Fine. This reflecting curved mirror has a center which is known as your pole. Now this reflecting surface has a center. Fine. This center is known as your center of curvature, and it is denoted by capital C. Fine. Next, this concave mirror has a focus which is denoted by capital F. Now next, a line which passes through the center of curvature, your focus, and the pole is known as your principal axis. So this line is known as your principal axis. Fine. So let us consider a light. This is my incident light and it is moving from left to right. So when a light strikes the reflecting surface, okay, this light will undergo reflection. Now after reflection, it will pass through the focus as you can see in this figure. Clear? Now the similar case is for your convex mirror. Fine. This is your convex mirror. The convex mirror has a focus F. It has a center of curvature C. Now consider a light. Okay, this light is moving parallel to the principal axis. This line is your principal axis. Fine. So consider a light is moving parallel to your principal axis. Fine. So after reflection, what will happen? The light will get reflected back. Okay, this light is reflected back and it moves in the northwest direction. Clear? It is moving in this upward direction. Fine. If this one is your north, this one is your south, this one is your east, this one is your east. Fine. This one is your east, this is your west. So you can clearly see the light after reflection, it moves in the northwest direction. Okay, but the reflected light is appeared to be moving from which point? It appears to be coming out of this point F. Yeah, can you see? This reflected light, it appears to be coming from this point F. Can you see? This yellow light represents your incident light for your convex mirror, and it is moving parallel to your principal axis. After reflection, it moves in the upward direction. So it appears to be, okay, it's not actually coming from this point F. From where it is coming from this point. But it appears to be coming. It looks like, it seems like it is coming from this point F. Fine. So it appears to be diverging from the focus. So for the convex mirror, the first rule states when an incident light moves parallel to the principal axis after reflection, it diverges from the focus. Is it clear? Now, your second rule states that a ray of light passing through the center of curvature of concave mirror or directed in the direction of the center of curvature of a convex mirror is reflected back along the same path as shown in the figure. So let us first understand for your concave mirror. This is your concave mirror. This concave mirror has a center which is known as your center of curvature and it is denoted with capital C. So whenever a light is directed towards or it is passing through the center of curvature after reflection, it will move back along the same path. Fine. So as you can see in this figure, the light is moving in this direction. This arrow denotes the direction of the incident light. So this light moves here. After reflection, it moves back along the same path. This arrow denotes the direction of the reflected light. So it is moving back in the same path. Fine. The same is true for your convex mirror. Consider your convex mirror. So when a light or when a incident light is directed towards the center of curvature, as you can see, this arrow denotes the direction of the incident light. So a light is moving towards the center of curvature, as you can see, but it is not actually going and intersect, or it is not going and actually passing through the center of curvature. Okay, it is directed towards the center of curvature. Fine. So when a light is directed towards the center of curvature, fine, it strikes the mirror. Now after striking the mirror, which is your reflecting surface, it is reflected back. Now the reflected light will move back along the same path, and this arrow denotes in which direction your light is moving. The light is moving back along the same path. Fine. So for a concave mirror, a light which passes through a center of curvature after reflection passes back through the center of curvature along the same path. For convex mirror, when a light is directed towards the center of curvature after reflection, it travels back along the same path. Note that in case of convex mirror, it does not passes through the center of curvature. It is just directed. Clear? Whereas in case of your concave mirror, it passes through the center of curvature. Your third rule states that a ray passing through the principal focus of a concave mirror or a ray which is directed towards the principal focus of the convex mirror becomes parallel to the principal axis after reflection as it is shown in the figure. So let us look for your concave mirror. This curved mirror is your concave mirror. Fine. This line is your principal axis. On this principal axis, this point is known as your principal focus and it is denoted with capital F. Fine. So when a light is incident on the concave mirror and it passes through the focus, fine, this is your incident light and it is passing through the principal focus, capital F, fine. So after it strikes your concave mirror, this light will move parallel to your principal axis. So in this figure, this yellow light represents your incident light and this blue line represents your reflected light. Fine. So the light which passes through the focus after reflection moves parallel to the principal axis. Now let us take a look for your convex mirror. This is your convex mirror. The convex mirror has a center which is known as your pole P and it has a point F which is your principal focus on this principal axis. Fine. When a light is directed towards the focus, okay, when a light is moving towards the focus, as you can see, this yellow light is approaching towards the focus, but will it pass through the focus? No. Okay, what will happen to this light? As soon as it strikes this reflecting surface, this light will be reflected back. Fine. So the light which is directed towards the focus of convex mirror after reflection passes parallel to your principal axis. So in this case, this yellow light represents your incident light which is directed towards the focus. Fine. This light directed towards the focus strikes the convex mirror. After reflection, it passes parallel to your principal axis. Yeah. Your fourth rule states that a ray ob incident obliquely to the principal axis towards a point P, pole of the mirror, on the concave mirror or a convex mirror, is reflected back obliquely. The incident and the reflected rays follows the laws of reflection at the point of incidence, point P, making equal angles with the principal axis and is shown in the figure. So let us first understand for your concave mirror. Now before we discuss for concave mirror, let us revise the laws of reflection. So what does your laws of reflection states? Suppose you have a reflecting surface. Okay, this is your reflecting surface. Fine. Now on this surface, let us consider a imaginary line. This is your imaginary line and it is perpendicular to your reflecting surface. Fine. And this imaginary line is known as your normal. Fine. So when a light comes and it strikes the reflecting surface at this point, this represents your incident light. It is intersecting the reflecting surface at this point, what happens to this incident light? So when it strikes the reflecting surface, this light will get reflected and it will move in this direction. Fine. So this is your incident light which is moving in this direction. This is the incident light which is moving in this direction, and after reflection it will move in this direction. Fine. Now the first law of according to this first law, the angle made by your incident ray, this is your incident ray, the angle made by the incident ray and the normal, okay, this angle is known as your angle of incidence. Fine. And this angle is denoted by I. Fine. Next, the angle by the reflected ray and the normal. Fine. This angle. This angle. Fine. This is represented by R and it is known as your angle of reflection. Fine. So your first law of reflection states that the angle of incidence is equal to the angle of reflection. Fine. Now apply the same concept here. So this is your reflecting surface. Fine. Now a light, this is your incident light. This light is moving obliquely. Okay, obliquely is like it is tilted. Fine. So this light is moving obliquely towards the point P. Fine. So what happens to the light when it moves towards this point? It will get reflected back. So as for this light, this is your incident light. It goes and strikes the mirror at the point P. Now after reflection, what will happen? It will move in this downward direction. Fine. Now here the incident ray and this principal axis. Okay, the incident ray and the principal axis. Can you see here? The principal axis which acts as a normal for this case. Okay, this principal axis will act as a normal, this dotted line. Fine. The angle made by the incident ray and the normal or your principal axis is known as your angle of incidence. Fine. And the angle made by the reflected ray and the normal is known as your angle of reflection. Fine. So when a light is moving obliquely or it is directed obliquely towards the point P, after reflection it will move obliquely. Fine. But in this case what happens? They will both move at the same angle. Why? Because of the first law of reflection. And according to the first law of reflection, the angle of incidence is equal to angle of reflection. The same can be applied for your convex mirror. When a light is directed towards the point P, after reflection it moves in this direction. Fine. So in this case also, the angle of incidence will be equal to angle of reflection. Fine. So we have discussed the four rules how the light will be reflected. Fine. The first rule states that, let us just quickly summarize. The first rule states that when a light moves parallel to the principal axis, okay, suppose let us revise, this is your mirror. When a light moves parallel to the principal axis, it passes through which point? It will pass through the focus. Fine. This was your first rule. Clear? Now your second rule states that when a light passes through the center of curvature, let us consider this point as your center of curvature. When a light passes through the center of curvature, it is reflected back and it moves back along the same path. Fine. This is your second rule. Now your third rule states that when a light passes through the focus, when a light passes through the focus, after reflection, what will happen? It will move parallel to your principal axis. Fine. And your final rule, rule number 4, states that if a light is directed towards the point P, what will happen? This light will go reflection, and in this case, what happens? The angle of incidence is equal to angle of reflection. Fine. Now, these are the 4 rules which are applied for both your concave as well as your convex mirror. Fine. Now, in our next class, using these 4 rules, I will explain how the images of the different objects are formed. Clear? Using these 4 rules in our next class, I will explain how the images are formed for different objects placed on different points of the principal axis. Is that clear? Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So thank you.